Hi everybody, today's lecture is over atomic theory and atomic history. We're looking at all the high points in the atom. Throughout the years we've had lots of ideas about what an atom is. We've had an atom just being a solid shape. Democritus and Dalton, they kind of had this idea. Through the years we've kind of come up and decided that no, the atom's made up of more pieces. You have Thomson, Rutherford, Bohr. They all thought the atom was made of more pieces, but they kind of had to go step by step to figure out where they were at. They couldn't just do this without the works of people before them. Even with the modern quantum theory, which is where we're at today, we've had to use the knowledge of what we had before. We're going to start today with Dalton's atomic theory. Dalton said that all matter is made of tiny particles. This is kind of a big deal. Some people don't understand. If they can't see it, they're not going to understand that we're made of tinier pieces. He also said the atoms of a given element are alike, but are different from the atoms of any other elements. So if we have gold atoms, all the gold atoms are going to be the same, but they're going to be different than silver atoms. He also said the compounds are formed when atoms of different elements combine in fixed proportions. His fourth one is chemical reactions involve a rearrangement of the atom, but not a change in the atom. So what this basically is atoms are going to be indivisible. What an indivisible atom means is the atom will not break down into smaller pieces, such as the subatomic particles, which we're going to discuss now with J.J. Thomson. J.J. is going to be one of those guys that discovers the subatomic particles. He's the first guy that really looks at the electron as a subatomic particle. So he says now it's not just this one solid piece. You actually have little tiny components that make up an atom. That is a huge step because now we have subatomic particles. With JJ's subatomic particles, they call it the plum pudding model. What I liken it to would be more like a chocolate chip cookie, where you have little tiny pieces scattered throughout the whole atom. The next one we're going to look at is going to be Rutherford. Rutherford's experiment, it might look confusing at first, but really it's not overly difficult on the concepts that he has right here. What Rutherford did is Rutherford shot alpha particles at a thin sheet of gold. Gold's super, super thin, and we can hammer it out really, really small. So basically we're shooting it at a single atom. What would happen normally is the thought that the atoms would shoot, or the alpha particles would shoot right through, and they would hit the back of the screen. That's not what happened though. Some of them were deflected. Some of them were shot straight back at him. And what he determined from that is there had to have been something really, really dense in the middle, and what he determined that to be ultimately was the nucleus of the atom. Our next pioneer is Niels Bohr. Niels went from Rutherford's and took it a step further. He looked at the nucleus, and then he determined electrons were in set orbitals. Now when he said they were in orbitals, those are energy levels. We'll talk more about energy levels later. But the electrons were there, and as they went further and further out, we could determine exactly where they were. They're kind of like orbiting planets. Ultimately, we're going to disprove that theory, but this is pretty groundbreaking stuff, even though we still use this model quite a bit today, and especially in this class. So we'll look at these. They're set numbers. We will definitely need to know how to do this. Okay, from here we move on to modern atomic theory. Modern atomic theory is basically from the 1930s on, where we've started to really think of a quantum mechanics model of the atom. These are such scientists, nuclear theorists such as Einstein, de Broglie, Schrödinger, Heisenberg. These are all very, very famous scientists, and they really did quite a lot of thinking about the atom. Earlier we said that we can find the atom by its orbit, where it's found. Modern atomic theory, you have an electron cloud, where you have a probability of finding the electron. So the odds of finding an electron in a certain area are going to be higher if the cloud is more dense. Modern atomic theory is very important, but what we're going to spend the majority of our time with is going to be Bohr's model. So we need to know the concepts of the modern atomic theory and probabilities. But other than that, we should be done with it. All right, Tuesday morning before school, I am looking for random acts of kindness, awesomeness in the hallway. High five it up, get after it. If you will do these things, you will be rewarded. See you Tuesday in class.